Hello everybody, we're back at the lab. Now, we've got our trusty friend, little Wireshark, and what I've got to demonstrate is basically a small little set of PHP pages that I've compiled and put up onto the same server we use for the FTP, which is just sitting in the internet in a commercial hosting farm. Basically the page takes a username and password, we click on the authenticate button and takes us to a resultant page which will display the username and password on the page, but then we'll actually pull the packet apart, have a look at the HTTP headers and see the UU encoded versions. Okay, so we start up our Wireshark capture, start, okay, and you should, yep, so you started. Now we go to this page. What we'll do is just refresh to make sure that the actual page itself is included. We'll enter a username, which I'll use my full name, Richard Lee, and a password. Let's use test pass 1, 2, 3, 4, and we'll authenticate. Oops. Okay, so it's just giving us back the array. Now we'll go back to Wireshark and we'll hold that capture. Okay, let's just have a look. There's a number of ways we can actually find out where we are. Well, I can find it pretty easy because I know that the page that we are hitting is process test password. So the page we came from was test password, which is here. So within there, this section here, that's the code for the page, which we can start deciphering. We don't really care about what's in there. It's basically the HTML form and whatever in that packet there. So it'll actually show us the data. Okay, and there's the code for the form that we've displayed. So if we keep going down, what we'll see is the post. So we can see we've got post and we've got the destination page. We're using the HTTP 1.1 protocol, and the form is a UU encoded or URL encoded form. Okay, so what we'll see in this post is the form items of UN value is Richard.Lee and PWD value is testpass1234. Clearly identified and text base in the HTTP header. So as you can see, not very secure. Okay, so usernames and passwords are insecure. I think most people now look for their, as we spoke about, look for their little security token. Visiting websites asking for username and password over HTTP is dangerous. Just don't do it. Don't even consider it. It's probably an untrusted and certainly a not secure website. Many authentication requests are based around accessing login details. I mean, let's face it, you normally have a form of content going somewhere. You don't fill it out just for no purpose these days. It's probably going into a database or going into open up a user account and further details. Financial institutions, obviously a great example, and I wouldn't think there's a financial institution in the world that would use the HTTP protocol for their authenticated website. Okay, not secure, don't use it for providing sensitive information for websites. Very easy. Okay, so now what we're going to do is demonstrate a HTTPS website. Okay, so that is what we'll actually use is the Commonwealth Bank. It's a nice easy one, secure, and I'll demonstrate how to show that it's secure. So we'll go back to Wireshark. Oops, hang on, we'll go back to here, and I've already got the website up, so now we'll go back to Wireshark. We'll start a new capture, continue without saving. Okay, so there she is. Alright, she's ready to capture. We'll refresh this page. As you can see, nice green, got that little lock here, HTTPS, nice and secure. We'll just sit in front of the keyboard here. Okay, so we've gone to log in. I've purposely entered incorrect details. But what we'll do is go and have a look at what that means over here. Okay. Okay, as you can see, there's a lot of packets being captured. Okay, and we're going to find it very difficult. There's the transfer of the certificate. That's 6611723-103 is actually the website that we're accessing. There's the transfer of the certificate. There's the handshake, the acknowledge, and now what we've got is just a whole bunch of transfers encrypted, which we can't actually see into. Okay, so what we see here, we've got a key exchange, we've got an encrypted handshake message. Now we start getting AUX and NORCs, so the servers are talking together. And somewhere here we'll have a transfer, which I'll look for. Okay. Again, a lot of handshaking. And here we go. Application data. Secure socket layer. So using TLS 1.2 socket, there's the data. No clear text, completely encrypted. We can't see what's actually in it. Again, more. Encrypted data, we can't see anything that's in there. More. Every packet, and they're about 1500 byte size packets, all encrypted, or 1360 packets. Yeah, 1360, 1400, all of them encrypted. We can't see any of the data in there. So this really is not helpful to us unless we can decode TLS version 1.2 encryption. We can't pull out destinations, we can't pull out what pages are being hit, we can't pull out any of the content transmitted, usernames entered, passwords entered. Okay, so again, all of this, TLS 1.2, all of our transfer is encrypted because it's all HTTPS. Okay. Encrypted alert, so everything's encrypted. We can't pull apart anything. So really, it's a waste of time, to tell you the truth. There's nothing we can see. We can't pull out host names. We can't pull out anything. Everything is encrypted within the packet. We can't pull it apart. So what we learn is HTTPS is secure. It can be used to safely communicate, safely transmit username and password. So perfect for any website that takes information from a client and puts it into a cloud server database, authenticates for personal information user accounts. Now, basically, the way the encryption works is a source of an encryption key is a trusted source like a Thwaite or a VeriSign key. So what you have is half of the encryption key sits on the host server, and half of the encryption key sits at the commercial authority that issues the certificate. So it basically means that no one's got both halves of the key, and once you've got both halves of the key, obviously you can decrypt it. So half of the key comes from here, half of the key is sitting on the server. The keys come together, they handshake, and they can decrypt the encrypted packet. Snooping can retrieve the actual host you go to initially, but can't retrieve the URL or content, so basically a waste of time. Okay, so in summary, the encrypted transmission or contents are important when sending information or content over the internet. You don't want to be compromised. There is no place for plain text. Now, I hopefully have demonstrated the insecure nature of plain text or decipherable protocols. The transmission of sensitive content on the internet with snooping, and basically you have to make the assumption that any content that's going over any wire can be intercepted, because whether it be fibre, Cat6 cabling, everything can be intercepted. I mean, let's face it, fibre is just light pulses. So, as earlier mentioned, it's not secure. Okay, so my recommendation is to avoid FTP servers for personalised authentication uploading sensitive content. That includes database connection details in PHP files, ASP files, ASPX files. Anything that you transmit can be interpreted, or can be read. So just think about that before you send things up. My recommendation for FTP would be only to use it as a download. If you downloading demo software or free software, SourceForge or something like that, you use FTP protocol, but don't do anything that's secure. HTTP transmission of sensitive details, don't do it. I think HTTP these days, people are pretty switched on. They don't get sucked into providing details on a non-secured website. Always make sure that you've got your little lock on your browser, and always make sure you're using a trusted browser as well. And the trusted browser will ensure that you're using a trusted SSL provider for the encryption keys. Has anyone got any questions? No? Okay, we'll move on. I guess just to highlight, I've actually made the presentation a little bit longer because I was aware that it was going to be very difficult to get some questions, but I'm happy to answer any questions via email or phone if there's any that come out of this presentation. And obviously there's a list of references at the end of the presentation which will be in the information pack, which I will be uploading very shortly. But other than that, thank you for your time, and hopefully the quality of the presentation is sufficient. Apologies about the lighting and everything else, but thank you very much for your attention.